Honest Chemistry. This is Lesson 12 on stoichiometry grams. So let's talk about what is stoichiometry. Stoichiometry is the math involved in using a chemical equation to determine how many reactants you will need to produce a certain amount of products and how much products you'll get out of that. So just think of it as the math of using chemical equations and the overall procedure of using chemical equations to determine different things. So let's go ahead. So we measure in grams, liters, and molarity. Liters and molarity we'll get to later. Grams is what we're going to talk about right now. And then we need to convert to moles. So go ahead and put this up. All right. So what does that chemical equation down at the bottom need in order for us to use it? Well, you can read that chemical equation in two ways. That there's one molecule of CH4 plus two molecules of O2, oxygen, is going to produce one molecule of carbon dioxide and two molecules of water. That's one way to read it. The other way to read it is we can use, instead of one molecule or two molecules, we can use these big baskets of molecules, these massive numbers of molecules called a mole. By the way, that little animal is also called a mole. It has nothing to do with each other. It's just a way to remember it. So I could say that I have a mole of methane, CH4. That is, I have one basket of 6.022 times 10 to the 23rd molecules. That massive number that we talked about. And then I have two baskets, or 2 moles, of O2. So I have two baskets, or 2 times 6.022 times 10 to the 23rd molecules of oxygen. And from that, I'll get a basket of carbon dioxide, 6.022 times 10 to the 23rd molecules of CO2, and 2 baskets, or 2 moles, or 2 times 6.022 times 10 to the 23rd molecules of water, H2O. Well, we've got a problem. If we're talking about molecules, individual molecules, 1 and 2, it's too small for us to see and for us to measure. So we can't really use that chemical equation dealing with just a single molecule or 2 molecules. It's just too small. On the other hand, if we're dealing with moles, those big baskets, the number is too large. We can't possibly count how much is 6.022 times 10 to the 23rd, right? We used our example. It would take you over a million times the age of the universe to count a mole of anything. So it's too big a number for us to work with. So unfortunately, we seem to be, stuck at both ends. The small end we can't use, the big end we can't use. So how do we use this equation then? And the answer is, fortunately, there's a way to do that. We can measure the mass of a substance as long as we know we have a pure substance. So CH4 is a compound, but it's a pure substance. It's not mixed up with something else. O2 is a molecule, is oxygen, oxygen molecules. It's a molecule and it's a pure substance. CO2, it's a compound with carbon and oxygen, but it's still a pure substance. If you just have purely CO2 and nothing else, it's a pure substance. And the same with water, H2O, it's a compound, but if you have pure water, in other words, you haven't stirred some salt or something into it, then it is a pure substance. So as long as you know you're dealing with a pure substance and what it is, what that substance is, and you know the mass, that is something you can measure on that little scale up at the top, which we have in our classroom. You can get the mass of it. You can convert the mass of any substance into the number of moles. That is the number of molecules that you have, or those big baskets of molecules that you have. So what this little graphic organizer is telling you is our world is measured in grams. We can use a scale. We can measure CO2, for example, on a scale and get some mass in grams. But the chemical equation doesn't understand masses. It doesn't understand weights or masses. It understands numbers of molecules. But fortunately, we have something called the molar mass, which we calculated in the last lesson, and it simply relates how many moles of a substance to how many grams that substance weighs. So we can work in the world of grams with a scale. The chemical equation needs us to translate that into moles. And so that's what the translator is. The molar mass is like a translator. It's like if you if one person speaks Spanish and another person speaks English, but they don't speak the other language, then you need a translator. You need somebody who speaks both English and Spanish to translate between the two people. Okay, well that's the same thing here. We speak in the language of grams that we can weigh on a scale. The chemical equation speaks in terms of a number of particles, a number of molecules, a number of atoms, which we can't possibly count. So what the translator does is it converts our world of grams into the number of molecules or moles that the chemical equation can understand. And then once the chemical equation is done doing its thing, doing its work, then we can go use the translator to go backwards from the chemical world back to our world of grams, so we know how many grams. So for example, if we knew how many grams of CH4 and O2, we could do that by measuring it on a scale. We then we convert that to moles. We go down, we put that in our chemical equation down below, and then we figure out how many moles of CO2 and how many moles of O2 will come, or of H2O will come up with. And then once we know that, we can use the molar mass for CO2 and H2O to figure out how many grams we have. And again, that gets back into our world. So let's run through some examples in this lesson and you'll see how this works. Okay, so up at the top there is a question. How many moles of CH4 are required to form 8 moles of H2O? So you're going to see this graphic organizer and I want you to get used to using it while you're learning how to do this. So you see a top row of empty boxes and next to it it says our world in grams. So if you're given some number of grams, then what you can do is convert that into some number of moles using the translator called the molar mass. That gets you into the chemical equation, which is the chemical world, and that's in that blue dashed box. Then once you've done whatever you need to figure out inside of the blue dashed box, inside the chemical equation, you can use the molar mass, the translator, to come back out and figure out how many grams you have of some substance. Now in this particular example, we're not dealing with grams at all. I'm simply asking, the question simply asking, how many moles of CH4 are required to form 8 moles of H2O? So the first thing you want to identify is what is the question looking for. And what I'd like you to do is to draw these graphic organizers. There's 4 problems, so you have to draw 4 of them. It doesn't take that long. Draw them as neatly as you can. And then you want to first identify what are you trying to get. Anytime you're trying to solve a problem, you want to know where am I trying to get to? What am I trying to figure out? So you're trying to figure out how many moles of CH4. So what we're going to do is put a question mark in that box. So you see the red box with the question mark in it now. Now, why did we put it in that box? Because that's the CH4 box. That's the column for CH4. And moles is what the chemical equation is dealing in. That's what those numbers in the chemical equation mean. They mean numbers of moles. So that's what we're trying to find, is how many moles of CH4. Now, are required to form 8 moles of H2O. So figure out which box would that go into. 8 moles is the number you're given, moles of H2O. So where would you put 8 moles of H2O so that you could start this problem? And the answer is it would go right there. So it's in the H2O column and it's in the moles row. Okay, the moles is inside the chemical equation. So we can take 8 moles of H2O and figure out how many moles which we want to obtain at the end of the reaction, and figure out how many moles of CH4 that we need to give us 8 moles of H2O. Now notice something. Mathematically, this moves from right to left, from the 8 over to the question mark, which is our final answer. But chemically, it's moving from left to right. It's moving CH4 plus O2 is giving us CO2 plus H2O. So just understand that as we do the math in this equation, we're starting with the 8 over on the left, and we're going to end up with that question mark answer over on the right. Okay, now, the only relationship we know between CH4 and H2O is in moles. It's inside that chemical equation, and you can see that's a one-step process. So what do we know about the relationship of H2O and CH4? we know that we need 2 moles of H2O for every 1 mole of CH4. That's what the chemical equation tells us that relationship is. In other words, you need twice as much water, or you're going to get twice as much water as you put in CH4. If you put in 1 mole of CH4, you're going to get 2 moles of water. If you put in 2 moles of CH4, you're going to get twice that much, or 4 moles of water. If you put in 100 moles of CH4, you're going to get twice that much, or 200 moles of water. So it's a ratio, it's a relationship between CH4 and water. So what you do, the way you write this equation is, you start off with what you're given on the left side. That's the way you always start. A math equation flows from left to right. So we know it's 8 moles of water we're trying to get to. And on the right side then, it's some number of moles of CH4 that we're going to have to start with. And that's what we're going to have to figure out what that number is. So we need a relationship between those two, and we just stated what that relationship is. That there's 2 moles of H2O, this is what the chemical equation is telling us. 2 moles of H2O for every 1 mole of CH4. So there's 2 ways you can write that. So there it is, 1 mole of CH4 for every 2 moles of H2O. So you can either write it this way, that there's 2 moles of H2O for every 1 mole of CH4, or there's 1 mole of CH4 for every 2 moles of H2O. Think about that. Those are saying the same thing, right? I can say that 1 dime equals 10 pennies, or 10 pennies equals 1 dime. I can say that relationship either way I want, and they're both true. So that's what we're doing. We're saying the relationship between water, H2O, and CH4 2 different ways. So the first ratio there is saying, the way you would read that is there's 2 moles of H2O for every 1 mole of CH4. And the ratio, the fraction over on the right, is saying there's 1 mole of CH4 for every 2 moles of H2O. Those are both true statements. And we obtained both of them, by the way, from that statement down below. 1 mole CH4 equals 2 moles H2O. But what we have to figure out is which of those 2 ratios do we put in our equation. So the way you make that determination is, first of all, you ask, what unit of measure do I want to end up with? And what you want to end up with is moles of CH4. That's at the end of the equation. That's where your answer is. What do we need to cancel out? Well, we started off with 8 moles of H2O, so moles of H2O, but that doesn't appear in our final answer. So we want moles of H2O to cancel out. We want to be able to cancel it. Which one of those 2 ratios do we put into that blank space up above in order to get moles of H2O to cancel and moles of CH4 to appear in the final answer? So think about it. Which one would you choose? And you should choose this one. So which one would you choose? You should choose that one. That's the one you're going to put up there. 1 mole of CH4 for every 2 moles of H2O. Why is that? And keep in mind, at this point, we're only canceling units of measure. We're not dealing with any numbers yet, okay? First, you have to get the units of measure to line up and cancel properly, and then you go to computing the numbers. So if we see what happens to moles of H2O, it cancels and cancels. If one is on the top, the one on the left is on the top, and the other one is on the bottom. And so moles of H2O cancels. And the only thing we have left, I call it the last man standing, is moles of CH4. That doesn't cancel with anything, so that's going to end up being the units for your final answer, and that's what you want, because look at what the question is asking. How many moles of CH4? That's what you're trying to find out. Now that you've gotten the units to line up, now you go ahead and compute the numbers. And the way you do that is you multiply everything on the top, divide by everything on the bottom. So it would be 8 times 1 divided by 2. Be sure you understand why that is. The 8 is on the top. If you just have a single level like 8 moles H2O, it means it's in the numerator. It's on the top. Okay, so it's 8 times 1 divided by 2. So there's the 8 times 1 right there is 8. And then you divide by 2, and that's going to give you 4. So, in other words, in order to get 8 moles of water, you need 4 moles of CH4. And if we want, we can go ahead in our graphic organizer below, and we can draw that in right there. So you see it appeared in that red box down at the bottom. So again, look at the chemical equation. It's telling us we're going to get 2 moles of water for every 1 mole of CH4 that we put in. So if we put in 4 moles of CH4, we're going to get twice as much water. It's a 2-to-1 relationship. However much CH4, however many moles of CH4 you put in, you're going to get twice that many moles of water. We wanted to end up with 8 moles of water, so that means we needed to put in 4 moles of CH4. So that again is a 2-to-1 relationship. 8 to 4 is 2-to-1 relationship. And that's how you do this problem, all right? It seems like a lot of writing. It's going to take practice, but when you practice, it'll start to come through. It'll start to make sense, okay? Again, it's not hard, it's just new, and there's a difference between the two, all right? Okay, now we're going to do one that's a couple of extra steps. Notice this was only one step. We only needed that one conversion of moles of H2O to moles of CH4 to do this. Now we're going to do a problem that requires 2 steps. So let's read the question up at the top. How many moles of CH4 are required to form 3.2 grams of H2O? So it's kind of asking something similar. It's asking about moles of CH4, but now you don't want moles of H2O, you want grams of H2O. So think about this in that graphic organizer you see on the screen. Where are you going to put your question mark? Your question mark, you want to find out how many moles of CH4, and what you're starting with, the one thing they give you to start with is 3.2 grams of H2O. So where are you going to put the 3.2, and where are you going to put the question mark for how many moles of CH4? So think about it. Pause if you need to. Okay, here we go. So now we have to deal in our world. That's the world of grams. That's things that we can measure. So how do we know we have 3.2 grams of H2O? Well, we can measure it on a scale. That's something that is in our world that we're able to work with, is grams of a substance. Okay, so the 3.2 grams is going to go right there. See if you understand why. First of all, it's in the grams row up above. Our world is in grams. It's measured on a scale. And it's in the column up above H2O. So that's 3.2 grams of H2O. Now, where do you want your question mark, what you're trying to find out, which is moles of CH4? Where do you want that to appear? Think about it. And that's going to appear down there in the bottom left, the question mark. Notice that that is in the moles row. It's inside the chemical equation. It's a number of particles, a number of moles, a number of molecules, and it's in the CH4 column. So what you need to do mathematically is get from 3.2, which is your known quantity, known number, to the question mark. And that'll tell you how much CH4 you would have to produce 3.2 grams of water. Now notice again, the chemical equation is flowing from left to right, from CH4 and O2 over to CO2 and water. But mathematically our equation is starting with 3.2 and it's ending up with the question mark. So that's the way we're going to write the equation. So the way you always write a math equation is what you know goes on the left side of the equation. What you're trying to find out goes way over on the right side of the equation. So what we're going to need here is 2 conversions. First one is we have to have the molar mass of H2O. In other words, we need that translator that converts from grams, which is something we can measure on a scale, into moles, which is a number of molecules that the chemical equation speaks in terms of. It doesn't understand grams, and we understand moles, but we can't possibly count them, so we can't use that. So we need something that relates those two. That's our world versus the chemical world. So we first use a molar mass conversion to get us from grams of H2O to moles of H2O. Next, we're going to use a second conversion to get us from moles of H2O to moles of CH4, and that's ultimately what the question is asking for. So this is a 2 conversion problem. Notice that that second conversion is exactly the same as the last problem. It's getting us from moles of H2O to moles of CH4. But we have the additional conversion now, getting grams of H2O into moles of H2O. And that's that first conversion, those down arrows there. So look at the equation that we put together up above. Way over on the right side is what we're trying to find. It's moles of CH4. That blank space after the equal sign means that our answer is going to go in that space. And what did we start with? We started with grams of H2O. So now we're going to need to build two conversions here. So I'm going to just draw two boxes to represent those two conversions. All right, so here's the first relationship. It's from grams of H2O. It's relating grams of H2O to moles of H2O. And that molar mass conversion is 1 mole of H2O equals 18.02 grams of H2O. Now, where did 18.02 come from? It came from your periodic table. One oxygen is 16. Just look at your periodic table for atomic mass, or we're going to now call that molar mass. And each hydrogen is 1.01, and there's two of them. So that's 2.02 for hydrogen. So 2.02 plus 16 equals 18.02. So a water molecule, a mole of water molecules is 18.02 grams. Again, you just use your periodic table to come up with these molar mass conversions. Okay? So now we can create two ratios. There are 18.02 grams of water for every 1 mole of water, or there's 1 mole of H2O water for every 18.02 grams of H2O water. Those are both true statements. Again, I can say there's 1 dime for every 10 pennies, or I can say there's 10 pennies for every 1 dime. They're both true statements, and these are both true statements, but only one of them is going to help us. So which one of those two ratios do you put in the first box? Think about it. So think about it. You have 3.2 grams of H2O. Grams of H2O does not appear in your final answer, so it has to disappear. So which one of those two ratios do you put up there to make grams of H2O disappear? The answer is you would put this one. Now we're going to put that in there. So now grams of H2O is going to cancel with grams of H2O. Remember, if you just have one level, 3.2 grams of H2O, it's in the top. It's in the numerator. Okay, it's on the top. So you have grams of H2O on the top, grams of H2O on the bottom, like that, so they cancel out. Now notice we're not doing anything with numbers at this point. We're only dealing with units of measure and the substance, grams of H2O, grams of H2O. So we've taken care of that first box. Now the second one, look down at your graphic organizer down below. By the way, I'm going to go ahead and I did the calculation. So 3.2 times 1 mole H2O over 18.02 grams of H2O gives you 0.18 moles. You see that appear down in the bottom right box. You normally don't do intermediate calculations like that. You don't do that. But I'm doing it just to illustrate how this problem is flowing in the graphic organizer step by step. So we're now at the point what you see up above is 0.18 moles of H2O. Now I need to get from moles of H2O to moles of CH4 to get my final answer, because that's what the question is asking for. Okay, so what we do is look at our chemical equation again, and we see that there's 2 moles of H2O equals 1 mole of CH4. And so we can write the same two ratios we wrote on the last slide. That there's 2 moles of H2O for every 1 mole of CH4, or there's 1 mole of CH4 for every 2 moles of H2O. So which one of those two ratios are you going to use? Well, you can figure it out in one of two ways. The most obvious to me is you want your final answer to be moles of CH4. That's our final answer units of measure. So we would like the one with moles of CH4 on the top. The other way to look at it is over there in the first box up on the top, we have moles of H2O sitting there. That does not appear in our final answer, moles of H2O. So we want that to cancel out. So we want to pick one of these ratios that makes the moles of H2O cancel out and the moles of CH4 appear in the final answer on the top so that it appears in the final answer. So which one is that going to be? Think about it. It's going to be this one. So we're going to go ahead and put that up here. So the moles of H2O cancels there and there. And the only thing we have left, I call it the last man standing, is the moles of CH4, which is what we want because that's the unit of measure for our final answer. The only unit of measure you should be left with at the end is the unit of measure you want to have in your final answer, and we do. Everything else canceled out. Now that you've done that, you can now do your math on your numbers because our units work out, so now we can do the math on the numbers. So we're going to take the 3.2 over there on the far left, upper left. We're going to multiply that by 1, and then again by 1, and then we're going to divide everything on the bottom. That's divide by 18.02, divide by 2. So you can do that all in one calculation on your calculator, and when you do that, that's going to give you 0.094 moles of CH4. And if you want to write it in your graphic organizer, you don't have to, because on your sheet, on your assignment, you're going to be using that graphic organizer over and over, so I would write on it in pencil so you can erase each time that you use it. But in this one, we're just going to use it once, so I'm going to go ahead and write that answer over there. And you see up above CH4 in the moles row, it says 0.094. In other words, what is the interpretation of this? It would take 0.094 moles of CH4 to produce 3.2 grams of water at the end of the day. Okay? Again, you may want to watch this a few times so that this concept sinks in. Okay? It's not supposed to be easy. Okay, so just keep that in mind. Okay, finally we're going to go one more problem here and be done. And now, how many grams of H2O can be formed from 5.2 grams of CH4? So now we're starting off with a measure that's in our world, grams, something we can measure on a scale, 5.2 grams of CH4. And we want to end up with a measure that's also in our world, grams, something we can measure on a scale, in this case, grams of water. So think about it. Where are you going to put the 5.2 and where are you going to put the question mark, which is how many grams of water or how many grams of H2O? Think about it. Give you a second. Pause the video if you need to. Okay, so here goes. So the 5.2 grams of CH4 is what we're starting with, and that's in the grams row, our world that we measured on a scale, 5.2 grams of CH4, and it's up above CH4. It's in the column with CH4. So it belongs in that box in the upper left. Now where's the question mark going to go? We need to find grams of H2O. So it's going to go there. There's the scale. It's going to go there. It's in the grams row, something we can measure on a scale, and it's up above H2O. It's up above the H2O column. So now we need to get from 5.2 grams of CH4 to some number of grams of H2O. Now you might ask this question. Can't you just go straight across? Isn't there some conversion of grams of CH4 to grams of H2O? The answer is no. No such conversion exists. You can't do that. So what you have to do is you've got to go into the chemical equation, move across the chemical equation, and come back out. So let's see how that works. So we're going to take our 5.2 grams of CH4 we're starting with, and we're going to go through the molar mass for CH4. That is, there's 1 mole of CH4 for every 16.05 grams. How did we get 16.05? And again, I'm talking you through this, but write it down and figure this out. 1 carbon and 4 hydrogen. So each hydrogen is 1.01. Multiply that by 4, you get 4.04. And then carbon, look at your periodic table. I'm getting all these numbers off the periodic table. Carbon is 12.01 for the molar mass. So 12.01 plus 4.04 gives you 16.05 grams for 1 mole of CH4. So now that translator allows us to convert from grams of CH4 to moles of CH4. And that'll go in that box on the bottom left-hand corner. Now we need to go across and get from moles of CH4 to moles of H2O. You can only move sideways, laterally, horizontally, however you want to think of it, inside the chemical equation. Up there where you see the red arrow with all the X's through it, you cannot move sideways outside of the chemical equation. We don't know a relationship between grams of CH4 and grams of H2O. So we move sideways inside the chemical equation because we know there's 2 moles of H2O for every 1 mole of CH4. We use that relationship on the last 2 problems. Now, third, we want to get back to that question mark, so we need to come back out of the chemical equation through the molar mass of water, and that'll give us our final answer in grams of water. It'll tell us how many grams of water will we get if we combust 5.2 grams of CH4. So you notice it's a three-step process. You're going to need three conversions. Conversion 1, grams of CH4 to moles of CH4. That's over on the left. Step 2, moles of CH4 to moles of H2O. That's the sideways arrow inside the chemical equation, inside chemical world. And finally, the third conversion from moles of H2O up to grams of H2O, where the question mark is, and that will give us our final answer. So here we go. We're going to take that arrow with the X's away because it's not relevant to us anymore. So there's our initial chemical equation. There's 5.2 grams of CH4 way over on the left of the equation. That's what we're starting with. And we want to know some number of grams of H2O way over on the right. And you see I've written it small because we're going to need a lot of conversions in here. So here we go. So we're going to need those three conversions we just talked about. So the first one is 1 mole of CH4 for every 16.05 grams of CH4. That's the translator. That's the molar mass that gets us into the chemical equation. So there's the two ratios. Again, just convince yourself those are both true statements. So which one, try to figure this out on your own. Which one are we going to want to put in that box? Remember, grams of CH4 does not appear in the final answer, so we need it to cancel out. Which one are we going to put in the box up above? The answer is this one. So we put that up there, and we end up with grams of CH4 canceling with grams of CH4 right there. So right now we have some number of moles of CH4. Again, we don't normally do the conversion at this point or total anything, but I'm going to do it for the sake of your seeing where we are. So look down in the bottom left-hand box, 0.29 moles. We've converted grams of CH4 into a number of moles of CH4. Now that we're in the world of moles, in chemical world, we can now move sideways and get over to where water is. So look at the look at the relationship between moles of H2O and moles of CH4. It's the exact same relationship we've used in the last two problems, and here it is. 1 mole of CH4 equals 2 moles of H2O. So go ahead and write the two ratios. There they are. So now, which one do you want to put in to that box up above? So think about, what do you need to cancel out here? Well, look at that first box up on the top. 1 mole CH4. So very top, the box on the left. We don't have moles of CH4 in our final answer. We have grams of H2O. So we need moles of CH4 to cancel. So now ask yourself, which of these two ratios are going to make moles of CH4 cancel? The answer is it's going to be this one. So we write it there, and moles of CH4 cancels with moles of CH4, and so now we've gotten that second conversion in. Alright, and now once we do that calculation, you end up with 0.58 moles of H2O. Look down at the bottom right box, 0.58 moles of H2O. Now we're ready to come back out of the chemical equation, back into our world, for a final answer of how many grams of H2O we're going to be able to have. So we need to use the molar mass for water for H2O, and that's simply this: 1 mole H2O equals 18.02 grams of H2O. Okay, so we're going to write two ratios out of that. Okay, so now which one are you going to use? Now you have two ways to figure out which one to use. What is your final unit of measure? You want that on the top of the ratio, and what makes moles of H2O cancel out? That unit that's in the middle box there up on the top. You need that to go away because that's not in your final answer. So which one are you going to use? You're going to use this one. And so you put that there. Moles of H2O cancels with moles of H2O. The only unit of measure left is grams of H2O. That's the last man standing, and that's your final answer. So you know you've set up your equation properly. Okay, wow, that was a lot. Okay, so here we go. Now we multiply everything on the top and divide by everything on the bottom. Okay, so 5.2 grams times 1 times 2 times 18.02 divided by 16.05 divided by 1 divided by 1. And when you punch all that into your calculator, you end up with 2.9 grams of H2O. So if we combust 5.2 grams of CH4 methane we'll end up with 2.9 grams of water. And we can go ahead and in our graphic organizer, we can replace the question mark with 2.9 grams. So again, you needed those 3 conversions. You can't move from grams to grams. You have to go from grams into the chemical equation, convert it to moles, then from moles to moles inside the chemical equation, and then come back out from moles to grams for your final answer. So it's a 3-step process, okay? All right, guys, this is a video you may want to watch a couple times, all right? It is not easy. It's going to take practice to get good at this, but the sooner you start practicing and the quicker you do the problems, the quicker you'll get it. It's just that simple. The way you should look at it is it's going to take 25 of these types of problems to get good at it. So if you can do those 25 problems in the next 4 days, then you'll get good at it. If you don't, if you delay and put it off and it takes you 3 months to do 25 problems, then it'll take you 3 months to understand it. So just jump into these problems, come to me for tutoring, and I'll be glad to help you, okay? All right, so that's it for the lesson, and we'll see you on the answers video for this lesson.